Okay, factoring quadratics. This one is a special case. There's two different ways to do this one. If you want to do the shortcut, we'll talk about that way in a second. First thing I want to do is I want to kind of expand this out to have a c, so 2y squared plus 6y plus 0 equals 0. That means that my a is going to be 2, my b is 6, and my c is 0. Well, all of those are divisible by 2. So I'm going to divide everything by 2. When I do this, I get y squared plus 3y plus 0 equals 0. So I asked you guys to take the first number, the a, which is 1, and the last number, which is 0, multiply them together. 1 times 0 is 0. I'm looking for two numbers that multiply together to give you 0. But when you add those same numbers together, you have to get positive 3 because that's your b. So if you think about it, 3 times 0 is 0, and 3 plus 0 is 3. So it's going to be y plus 3, y plus 0 equals 0. And we solve both of these. We get y equals negative 3 and y equals 0. If I look at this and I want to know the shortcut, I look at these. Remember how we always find the greatest common factor? Well, I can not only divide out a 2, I can also divide out a y. So I can take both of these and divide out 2y. So the 2y comes out front. I got y plus 3 left in the middle equals 0. And this y plus 3, that's the same as this one down here. And the reason why this is a 2y, well, we know that y plus 0 is just y, right? And when we divided out the 2, technically there's a 2 out front here, so that makes that 2y. Well, you say 2y equals 0. Divide by 2, you get y equals 0. And then you do y plus 3 equals 0, subtract 3 from both sides, you get y equals negative 3. So either way, the special case or not a special case, they both work here. Okay, algebraic proofs. Proofs are just a way to organize your information, okay? So basically, it's just like a step-by-step process in how you're doing something. A lot of times when we think about things, we leave out steps, and if we're trying to explain it to somebody else, they don't do it exactly how we want it to happen. So proofs are a way for us to organize our information step by step by step. We have a couple different types of proofs, and today we're just going to practice what we call two-column proofs. Well, I wanted to remind you guys of your algebra stuff. So we have addition property. That's just when you add something to both sides of the equal sign. Okay, subtractions when you subtract two things from both sides of the equal sign. Multiplications when you multiply both sides of the equal sign. Divisions when you divide both sides of the equal sign. We have this thing called the reflexive property, which seems kind of silly, but we're going to need it later. A equals A. It's just saying if it looks like a duck, it is a duck. Okay, symmetric property says I can write it as A equals B, or I can write it as B equals A. They're the same exact thing to me, right? We can say X equals 2, or we can say 2 equals X. It's the same thing. The transitive property, if A equals B, and we know that B equals C, what can you conclude about A and C? They have to be equal to each other. Substitution, remember every time we figure out what X is, we always substitute that number back in, so we replace it into our equation. And then distributive property, you know, when you have that number sitting outside your parentheses, you have to distribute it in. So the two things that you need to know about proofs is that there's a given and there's a proof. So the first part of this is our given. This was given to us. We were given that negative 5 times x plus 4 equals 70. The second half of this, x equals 18, this is what we're trying to prove. So if anything, if you can ever do a proof in your life, you should get these two things right. The first box under the statements is always the given, which is -5 times the quantity x plus 4 equals 70. The reason that we can put that in that box is because it was given to me. In the very last box, under statements, we write x equals -18. That's what we're trying to prove. So first things first, if I'm looking at this equation, -5 times x plus 4 equals 70. What's the first step to solving that equation? Well, first thing I have to do is distribute. Now, I like to do all my steps over here on the side because a proof is supposed to be nice and clean. So I'm just going to put this over here. It's kind of crunched. It's okay. I'll work on it. So we're going to distribute. When we distribute, we end up with -5x minus 20 equals 300, -300, equals, when we do this, we get -5x minus 20 equals 70. That's what goes in the next box. So we're going to write -5x minus 20 equals 70. How did we get from step 1 to step 2? We use the distributive property. Okay, what's next in solving this equation? Okay, we're going to add 20 to both sides. When I add 20 to both sides, I get -5x equals 90. So step 3, what we write down is -5x equals 90. How did we get from step 2 to step 3? Well, we use the addition property. Okay, it looks like I gave us too many boxes here, which is awesome. Okay. So what's my last step? Divide by -5, divide by -5. You get x equals -18. So step 4, x equals -18. That's what we were trying to prove, right? So that's awesome. And how did I get from step 3 to step 4? I used the division property. Don't forget to practice.